Okay, now we're going to look at this proof. And before we even go further, I want to correct something. This is prove that tan of x, not tan of alpha. So if we want to prove that, we're going to use our the identities we've seen. So yeah, this is sine x plus alpha is equals to cos x minus beta. So now we're going to expand. So it becomes sine x cos alpha plus sine alpha cos x. This is equals to cos x cos beta plus sine x sine beta. Now when we have most of the proofs that are going to be like this, we just, after expanding, we now collect like terms. Since the question wants us to have sine x, so we're going to collect like terms for sine x and collect like terms for cos x. So sine x, I'm going to bring this other term this side, so this is going to be sine x cos alpha minus sine x sine beta, and this is going to be equals to cos x cos beta minus sine alpha cos x. I can factorize out sine x here. This becomes cos alpha minus sine beta. This is equals to, here I factorize out cos x. This becomes cos beta minus sine alpha. So since I want tan, I can divide through by cos x, divide through by cos x. So what do I have? I have tan x into cos alpha minus sine beta is equals to cos beta minus sine alpha. Can divide through by cos alpha minus sine beta. Then I divide through by cos alpha minus sine beta. So here I get the answer as tan x is equals to cos beta minus sine alpha out of cos alpha minus sine beta, which is what we wanted to prove. So we've proved that. Now I think we can look at another example. So here we have, if sine x minus alpha is equals to this, prove that tan x is equals to 1. So it's going to be, we're going to use the same thing. We expand the identities we have. After expanding our identities, we collect like terms to look for what we want. So I'm going to pause the video, then I do that, expand, then okay, maybe since it's the second example, we can expand together. So this is sine x cos alpha minus cos x sine alpha is equals to cos x cos alpha minus sine x sine alpha. I'm going to collect like terms for sine x and cos x, since the question wants tan x is equals to 1. So here I have sine x, here I have sine x. I'm going to bring that this side. This becomes sine x cos alpha plus sine x sine alpha is equals to cos x cos alpha. I'm going to also bring this side plus cos x sine alpha. So I can now factorize out sine x this side, so I remain with cos alpha plus sine alpha is equals to cos x in brackets cos alpha plus sine alpha. I divide through by cos x. I divide through by cos x. So I get tan x cos alpha plus sine alpha. This is equals to cos alpha plus sine alpha. I divide through by cos alpha plus sine alpha. I also divide through here by cos alpha plus sine alpha. So we end up having tan x is equals to 1. So we've proved that. Then here the question says, if x plus this is equals to that. So it's going to be the same thing. So here we expand. I don't know if the space will be enough, so let me just start expanding there, and then sin x cos alpha plus cos x sin alpha is equals to 2 into cos x cos alpha plus sine x sine alpha. So here I get sine x cos alpha plus cos x sine alpha is equals to 2 cos x cos alpha plus 2 sine x sine alpha. Now the same thing like we've been doing, I want to collect like terms for sine x and cos. I'm going to bring sine x this side, so this is sine x cos alpha minus 2 sine x sine alpha. This is equals to 2 cos x cos alpha. I bring that on this side minus cos x sine alpha. Now going to factorize out sine x from this side, so I stay with cos alpha minus 2 sine alpha. This is equals to, factorizing out cos x here, I stay with cos alpha minus cos alpha minus sine alpha. Then I can divide through by cos x, divide through by cos x. So I have tan x into cos alpha minus 2 sine alpha, and we're saying this is going to be equals to cos alpha minus sine alpha. So we have tan x, I'm going to divide through by this. Tan x is going to be cos alpha, sorry, I forgot to carry. I think I forgot to carry something down here. There's a 2 here. Sorry, there's a 2. And the 2 out of cos theta minus 2 sine theta. So I divide through by sine, divide through by cos alpha. And remember why we're dividing through by cos alpha, it's because we are looking at our final proof and we want it to be tan, but here we have cos, so we can divide through by cos alpha, so this will become 2, and these others will become tan, so we end up having tan x is equals to 2 minus tan alpha out of 1 minus 2 tan alpha. So we proved that, and then now we have given that tan a minus pi out of 4. So what should we remember? Remember that say 2 pi is equals to 360. So here we want to, so we divide through by 2, divide through by 2. What is pi? Pi is 180. So if we have pi out of 4, it means it's 180 out of 4, which is the same as 45. That's in angles. But still, if you change your calculator to radians and you put maybe the tan of pi out of 4, it will give you 1. The only mistake you can make is to work with your calculator in degrees, but when you're inputting the figures in radians. So here we have, so this is what you're given. So let's first work with this. Let's expand this. So this will be tan a minus, I'm expanding this, out of 1 plus tan a tan pi out of 4. So this is equals to tan a, but now put this into the calculator. Make sure that calculator is in radians, or convert it to degrees such that you get 1. But regardless whether you work in with a pi, but you make sure your calculator is in radians, you still get 1. So we have 1 plus tan a. This is also 1 into 1. So we shall say tan a minus pi out of 4 is equals to tan a minus 1 out of 1 plus tan a. Now, but we said this is equals to a third, so we can just equate that to a third and say we have tan a minus 1 out of 1 plus tan a is equals to a third. So we have, with multiplying, we have 3 tan a minus 3 is equals to 1 plus tan a. we bring this side, so we have 2 tan A is equals to 4. So tan A is equals to 2. Then now we can, because now remember we want to solve this. If we wanted to just find the answer to this, we would have just now said A is equals to tan A. But now the question wants us to find sine of this. So we don't even need to go any further. We can just use our triangle. So this is opposite out of, like Sokatoa. So now we can draw our triangle here like this. And since this is angle A, if this is angle A, this is the opposite is 2, the adjacent is 1, then this is unknown, so this is A, B. From that thing, it's A squared plus B squared is equals to C squared. So this is 1 squared plus 2 squared is equals to C squared. So this will be 1 plus 4. So C is going to be square root of 5. So this side is square root of 5. So from this we can even get the sine of A being opposite out of hypotenuse from Sokatoa. So this is 2 out of root of 5. And the cos of A, we can get it from adjacent out of hypotenuse, 1 out of root of 5. Now we can come and solve this. Here we have sine A plus plus pi out of 4. So this is going to be, we use our compound angle formula for addition of two angles in a sine. So here we have sine A cos pi out of 4 plus sine pi out of 4, then cos A. Now what you should know is that cos pi out of 4 is the same as the cos of 45 in degrees. So you can come on your calculator, or you can use our, actually I think it's better we use our method for the triangle, because we want to have our answer in SADs. So let me see, what is the cos of pi out of 4 is, sorry, the cos of, so we first say what is sine A, this is 2 out of root 5, and then the cos of that is root 2 out of 2, that's in SADs, because we want to have an answer that's not an answer without points. But you can either, even if you chose to, but it would not be a very good answer, then even this is root 2 out of 2. This is just a rationalized SAD answer, but remember a few videos back we talked about how you can get the sine of 45 without using a calculator. So that's the way, after root of 5. So we have this is cos A, this is sine 45 or sine of pi out of 4, this is cos of pi out of 4. So this is the same as you saying what is cos of pi out of 4 and changing your calculator to radians, you would get 0.707, which is the same as root 2 out of 2. So here we now just have to simplify this. Here we get root 2 out of 2 out of 2 out of root 5 plus root 2 out of 2 out of root 5. So what do we end up having? We end up having this is equals to 3 root 2 out of 2 root 5. And so people usually can want to rationalize this further to say we have we now have this is 3 root 10, and now this is 2 root of 25. So this will be 3 root of 10 out of 2 times 5. So you see we have this is 3 root 10 out of 10. Okay, so we found the sine of A as pi out of 4. Okay, so let's now look at this faster. So we have if sine A is 4 out of 5 and cos B is 12 out of 13. Now from the previous numbers we've seen, we saw that anytime you're given these numbers, the first thing you do is to draw your quadrants. So I'm going to do both of them here, just next to each other, to make this simpler. So we say this is acute, this is obtuse, reflex, reflex. Same thing, this is acute, this is obtuse, this is reflex, and this is reflex. And said all students take coffee. All students take coffee. So we have this now here. We're going to use this for A. We're going to use this for B. Now here we're saying if sine A is 4 out of 5, so sine A is 4 out of 5, and we've said A is obtuse, so we're going to draw it here. So this is A, and this is from SOHCAHTOA, it's so. So 4 is the opposite, and H is the hypotenuse, so it's here. So we can find this by saying A squared plus B squared is equals to C squared. Then from here we can say we don't have A plus 4 squared, this is equals to 5 squared. So this is A squared plus 16 is equals to 25. So what we have value of AB? A value of A is going to be 3. Then now we come here, so this is 3, but you see when you put here 3, this is the negative direction, so you put a negative, because I told you this is an imaginary y and x-axis, so this is negative 3. Then now we come here where this is B, and we've said B is acute, so B is in this region, so this is B, and B SOHCAHTOA, this is adjacent out of hypotenuse, so here we have 12, and then hypotenuse we have 13, so we say this is A, B, C. So we say A squared plus B squared is equals to C squared. We have 12 squared plus B squared is equals to 13 squared. So what will so we say 12 squared, this is 144, plus B squared is equals to 13 squared is 169. So what's the value of B? Our value of B is 5. So we can now come and quote these different figures from this. So we already had sine A is 4 out of 5. So we say what is cos A? Cos A is adjacent out of hypotenuse. So this is cos A. Then we say what is tan A? Tan A is going to be opposite out of adjacent. So this is 4 out of negative 3. Come here, we also say we had cos B being 12 out of 13. And we got our B is 5. So we can say what is sine B? Sine B is going to be opposite out of hypotenuse. What is tan B? Tan B is opposite out of adjacent, which is 5 out of 12. So we found all of A and all of B. We have this. Now we just come and see what the question needs. So sine A minus B. So I think we can work out this. You expand, then you substitute the values. So I'm just going to quote for us the answer we're going to have. The final answer here is going to be 63 out of 65. Then tan A minus B out of tan A plus B. What are we going to have? We expand this, then we divide them. That's going to quote the answer. The answer is going to be 7 out of 3. So I think we've